ground, and we're now coasting downhill on that last 25% of the oil. Well, we have to ask, what's the Department of Energy doing about this? And here in 1998, we read about a new comprehensive national energy strategy, a set of policy goals that include halting the slide in U.S. oil production by the year 2005. Now ask yourself, what do you think is the chance that we can do anything more than put a little bump on the downhill side of the curve? Well, what does this mean? Let's look at the definition of modern agriculture. It's the use of land to convert petroleum into food. And we can see the end of the petroleum. Well, we have to ask about world petroleum. And in 1972, Dr. Hubbert produced this curve, and he suggested that he thought the peak of world production would occur around 1995. So we have to go to the data and see what has happened. Here, again, from our Department of Energy, but this now is world oil production, and we can see a long period of steady growth of oil production. There was quite a major drop right there. Then there was a recovery, then as simply an enormous drop, and a partial recovery here. So it's clear we're not yet over the peak. Each of those drops that you saw there was due to a price hike from OPEC. And I think that those drops in delaying the arrival of the peak are the reason for the fact that the peak will occur later than Dr. Hubbert had projected it to be. Well, I go back to my spreadsheet on my computer at home, and now in addition to just fitting the curve, since the curve has not started down, I can't get a very good fit for the curve for the area under the curve. But what I have to do then is to go to the geology literature and find out what is the consensus figure among geologists as to the total amount of oil we'll ever find on this earth. Well, this consensus figure is 2,000 billion barrels. Now that's uncertain. It has an uncertainty, maybe 40%, plus or minus 40%, so it's a very uncertain figure. But that's the consensus figure. If I do that and do the fit, there is the curve. The curve has a peak in the year 2004. Now if I say, let's assume there's 50% more oil than the geology consensus, then the fit gives me the year 2019 for the peak, and if I assume there's twice as much oil as the consensus figure, then the peak's back to the year 2030. Now look at those curves. In your life expectancy, you are going to see the peak of world oil production, and you've got to ask yourself, what's life going to be like on this earth when we have production declining and we have a growing population and a growing per capita demand for oil? Now just think about it. This isn't rocket science. This is something that we can all think about. In the March issue of Scientific American for the year 1998, there was a major article by two real petroleum geologists. One's in England, one's in France. They said that their estimate for this peak was that it would occur before the year 2010. So their estimate and the one I'm showing you here that I've made, these are in the same ballpark, and we're talking about the same kind of numbers. Now that analysis that was in Scientific American caused a lot of discussion, and in particular in Fortune magazine in 1999, commenting on this scientific analysis that was done by petroleum geologists, we find an emeritus professor of economics at MIT saying that this analysis is a piece of foolishness. The world will never run out of oil, not in 10,000 years. And so we have non-scientists telling us that petroleum reserves are greater than ever before in history, and we have geologists telling us that we're finding only 1 barrel of new oil for every 4 barrels we take out of the ground and consume. What is going on here? You've seen the figures. Here in 1999, U.S. lower 48 state January oil output hit a 50-year low, exactly what you expect as you're going down the right-hand side of the Hubbert curve. And one of Dr. Hubbert's favorite graphs is this one. And this is on a time scale from 5,000 years ago to 5,000 years in the future, and the age of fossil fuels is a little blip in the middle of the screen. Think about it. Well, we have to ask about new discoveries. Here in 1993, we read about the largest oil discovery in the Gulf of Mexico in the past 20 years, an estimated 700 million barrels of oil. Now that's a lot of oil, but a lot compared to what? At that point, we were consuming in the United States 16.6 million barrels of oil every day. Do the long division and you find that entire discovery would serve our needs for 42 days. And that's the biggest discovery they've made in the Gulf of Mexico in 20 years. On the front page of the Wall Street Journal in 1997, we read about the new Hibernia oil field off the south coast of Newfoundland. Please note this one line in the headline: now it will last 50 years. And let's go to that story in the Wall Street Journal and read about the Hibernia field. It's one of the largest oil discoveries in North America in decades. It should deliver its first oil by the end of the year. At least 20 more fields may follow, offering well over 1 billion barrels of high-quality crude, promising a steady flow of oil will be just a quick tanker run away from the energy-thirsty East Coast. They may find 1 billion barrels of oil in that undersea deposit. So 1 billion barrels, we are now consuming something like 18 million barrels a day. Do the long division, and that whole supply would meet our needs in the United States for 56 days. And what did that headline say? It said 50 years. Well, some people say there's nothing to worry about. And here we have a very prominent figure who says that we should grow corn, distill it into ethanol, and we can run the entire fleet of U.S. vehicles on ethanol derived from corn. And in support of this, he says today ethanol production displaces over 43.5 million barrels of imported oil annually. Now that sounds pretty good until you think. Now the first thing that you have to do is to ask, okay, 43.5 million, what fraction is that of the annual consumption of petroleum in vehicles in the United States? And the answer is it's 1%. You'd have to multiply corn production devoted to ethanol by a factor of 100 just to make the numbers come out right. And I've seen the suggestion that that would take all of the agricultural land in the United States. Now the second problem is it takes diesel fuel to plow the ground to plant the corn. It takes fossil fuels to make the fertilizer to make the corn grow. It takes more diesel fuel to tend the corn and to harvest the corn. It takes more energy to do the distillation. You finally get a gallon of ethanol. You will be lucky if there's as much energy in the gallon of ethanol as it took to produce it. It's a loser. Yet this guy says, don't worry, everything will be all right. Well, there's a lesson here, and the lesson is that we cannot let other people do our thinking for us. Let's take another look at world oil production. Now the graph here is slightly different from the one I showed earlier. What I'm showing here is per capita production of oil, which means that at every point I take the world production divided by the world population that year. Now the scale here on the vertical axis is liters per person each day. There's the number 2. Now 2 liters a person a day. 2 liters is about half a gallon. Now notice that the peak occurred in the 1970s, and it's been going downhill, and in the 1970s it was a little over 2 liters a person a day, and now it's down to about 1.7 liters per person each day. So we can say with confidence that any day that any one of us uses more than 1.7 liters of petroleum, directly or indirectly, we're using more than our share. Now, what's the average consumption in the United States? And the answer is it's up around 8 liters a person a day. So think about the inequity that's represented there. Now, there's something even more important in this graph. That peak in the 1970s, I think that historians in the future will look back at this peak and say